All right, we're going to be going over how to add and subtract matrices. So a few things to note before we get started, a few properties of addition and subtraction. So addition, I'll write it down right over here, and then we'll go over to subtraction. So addition, generally, or in all cases for this, A plus B is the same as B plus A, meaning that it is commutative. And another property that holds for matrix addition is that A plus B in brackets plus C is the same as A plus B plus C in this way, meaning this is the associative property, okay? So it doesn't matter the order, it doesn't matter if you swap them, you'll get the same answer. As for subtraction, it is not commutative, because if you do A minus B, it is generally not the same as B minus A in general, right? Because sometimes it might be, but in most cases it is not, and this is not a property that holds for subtraction. So this is not commutative. And this commutativity is only a property that holds for matrix addition. Okay, so let's go ahead and start with a few examples. So example number one, we're going to have a matrix A where there's 2, 4, 3, 6, 5, and 1. Let me just clean that up. Then we have matrix B, which is 1, 3, 7, 5, 2, and 4. And notice the dimensions. This is a 2 by 3 matrix, and this is a 2 by 3 matrix. So their dimensions are equal. Okay? You cannot add or subtract matrices unless their dimensions are equal. So let me write that down. Cannot add / subtract matrices unless they have equal dimensions. Unless their dimensions are equal. Okay, so if you have a 2 by 3 and a 3 by 2, you can't add this, it's not going to work. If you have a 3 by 3 and a 3 by 2, this is not going to work. A 4 by 4 and a 5 by 5, this is simply not going to work. Okay, so this is a very important point, that the dimensions of the matrices have to be identical. Okay, which means that the number of rows equal for both, and the number of columns is equal for both, right? So you have 3 columns here, 3 columns here, 2 rows, 2 rows. Okay, these have to match. So if we go ahead and add these together, let's see what we're going to do here. Just going to copy this onto the next page. If we go ahead and add these together, so we take A and B, or B plus A, it's the same thing, right? As we mentioned, addition for matrices is commutative. What we're going to do is very simple. We're simply going to add every single entry as it is. So we're going to add every entry to its corresponding entry. So this entry here in the first row, first column, is going to be added to the first row, the first column. This is the second column, first row. We're going to add it to the element in the second column and the first row of the second one. We're going to take 5, add it here. We're going to add 4 and 3, 6 and 5, and 1 and 4. Okay, so we're going to add every single corresponding element. So we're going to end up with 2 plus 1, 3 plus 7, 5 plus 2, 4 plus 3, 5 plus 6, 4 plus 1. Okay, so as you can see, this is just 2 plus 1. And if we take like this, for example, that's just 6 and 5. This is just 4 and 1, so on and so forth. Okay, and simply, we just simplify this down. We get 3, 7, 10, 11, 5, and 7. Okay, so this is it. We're done. So this is equal to A plus B, or if you'd like, B plus A. Okay, so now I'm going to go ahead and do the same matrices. We're going to do A minus B. Okay, so once again, it's just going to be the same thing. But here the order matters, right? So we're going to take the element in A and subtract it from the corresponding one in B. Okay, and the other way around would yield a different answer, as subtraction, once again, is not commutative. So what we're going to go ahead and do, we're going to get 2 minus 1 here. I'm just going to keep the matrix in sight. You're going to get 4 minus 3. You're going to get 3 minus 7, 6 minus 5, 5 minus 2, and 1 minus 4. Okay? So what you're left with is 1, 1, negative 4, 1, 3, and negative 3. Okay? And that's it. That is subtraction for this matrix. I'm going to go ahead and do one more example to really, I'm going to go a little bit faster on this one. And it's a little bit of a slow, it's a shorter example as well, because I'm going to use a 2 by 2 matrix. Once again, the dimensions do not have to be square. They just have to be identical for both matrices that you're doing, right? And a square matrix is one where the rows and columns are the same. So 2 by 2, or a 3 by 3, or a 4 by 4, that is a square matrix, okay? In this case, we have a 2 by 2 and a 2 by 2, so you look at the dimensions and you realize that they are identical, thus you can perform addition. So if we take A plus B, we get the following. We get 5 plus 3 here, you get 8 plus 4, you get 6 plus 1, and you get 2 plus 7, which is equal to 8, 12, 7, and 9. Okay? And that's it. That is addition, and this is the same as B plus A, and you can go ahead and check it for yourself. It will be the same answer. And then if you go ahead and do subtraction for this, A minus B once again, we will get 5 minus 3, 8 minus 4, 2 minus 7, and 6 minus 1, which will get you 2, 4, negative 5, and 5. And that is equal to A minus B, which is not, in general, equal to B minus A. I'm really drilling this just because it is a very important point. Subtraction is not commutative, addition is. And that is addition and subtraction for matrices.